Today's notes are from section 2.7, which takes what we did a couple class periods ago with graphing absolute value functions and what we talked about last class with transforming functions and puts them together. So we will be translating absolute value functions here in section 2.7. It is another way to graph absolute value functions. So the standard form for an absolute value equation, and it has to be in this form in order to translate it, is y equals a times the absolute value of x minus h plus k. Y equals a times the absolute value of x minus h plus k. The parent function, a parent function, we'll be using that phrase a lot throughout this year of Honors Algebra 2, but the parent function is the same as the original function, but without the translation. So if I take out the translation, which is right here and right here at the end, it's whatever's left over, which in this case would be y equals a times the absolute value of x. A times the absolute value of x is our parent function. Our horizontal translation, remember, is whatever's next to the h. I'm sorry, whatever is next to the x, which is an h. And the vertical translation is always whatever's added or subtracted from the end, which is the k. If you can translate the absolute value function, you can again only translate it if it's in the standard form. It's going to be faster than the way that we previously learned. So example 1 asks us to graph f of x equals the opposite of the absolute value of x plus 2 minus 3. Y equals the opposite of the absolute value of x plus 2 minus 3. Horizontal translation is whatever is next to the x. It's a plus 2. Remember, horizontal, it's always the opposite of what we would think, so plus 2 is actually left 2. And whatever is added or subtracted from the end is our vertical translation, and it is the same thing as you would typically think. Minus 3 means down 3. So we start at the origin, and we complete our translation. We go left 2, down 3. Left 2, down 3. That's going to be the vertex of your parabola. Absolute value function, v. And then we know that this v opens down because the number out front here is negative. And that number will always represent the slope, which in this case, it opens down with a slope of 1. So down 1 over 1, down 1 over 1, down 1 over 1. Go back to the vertex and go down 1, left 1. So the slope of this part is negative 1 and this part is positive 1. And we have our absolute value function. Again, it has to be in this form in order to do that translation. If I have a number right here in front of the x, some number other than 1, you cannot translate it. If it was 2x minus 4, we'd have to rewrite it so that it's in this form, which we'll talk about here in a little bit. Example 2 asks us to translate graph g of x equals 2 times the absolute value of x minus 6. G of x is equal to 2 times the absolute value of x minus 6. The minus 6 is next to the x, which means it's a horizontal translation. Minus 6 means to the right 6 units. I don't have a vertical translation at all, so we are not going up or down. We are just going right 6. And this v opens up because this number here is positive, with a slope of 2. Up 2 over 1, up 2 over 1, up 2 over 1, and up 2 left 1. Let's suppose we have something that looks like this. Y equals 3 times the absolute value of 2x minus 6 plus 9. First of all, because of this 2 right here, we cannot translate it as it's written. This is not write 6 up 9. Instead, we need to rewrite it so that it's in that standard form. So you have options here, actually. You can do it the first way that we learned, which was set 2x minus 6 equal to 0 and solve for x. And then set up an xy chart. 3 goes in the middle, 2 points on each side, and plug all those in for x and get all your y values and draw your graph. That's a great way to do this. It takes a little longer, but that will absolutely work. The other option that we have is to rewrite this so that it is in standard form and I can translate. So 2x minus 6, I can factor a 2 out of that, leaving me with x minus 3. When you factor that 2 out, we're factoring the absolute value of 2 out because it's inside the absolute values. Which on this one, it actually didn't wind up mattering because the absolute value of 2 is 2. So I have 3 times 2, 6 times the absolute value of x minus 3 plus 9. And now it's in standard form, so we could translate. We could go write 3 up 9, and then the v opens up with a slope of 6. This one is not in standard form. Standard form, the coefficient of the x inside the absolute value has to be positive 1. Now it's negative 1, so it's close. We can factor a negative 1 out. Negative x divided by negative 1 is positive x. 4 divided by negative 1 is negative 4. Notice this cannot be the same thing as this up here because this one opens up and this one opens down. So it is important if you are going to do it this way, when you factor, if you're factoring out a number, it is the absolute value of that number that you're factoring out. So now the absolute value of negative 1 is positive 1 times absolute value of x minus 4 plus 2. And then we could graph from there, right? 4 up 2 opens up with a slope of 1. So if we have something that is not in standard form, again, you have 2 options. Those options are to do the first way that we learned, set what's inside the absolute value equal to 0, solve, set up an XY chart. Or you can factor so that it is in standard form. If you do it that way, you do need to be careful if you factor out a negative number that you are taking the absolute value of that negative number previous to rewriting it. Example 3 says the graph of y equals 3 times the absolute values of x minus 2 plus 3 is then translated left 5, up 6. The question wants to know, what is the equation of the new graph? So I'm given a graph. I then move that graph left 5, up 6. We need the new equation. My original graph has a vertex. Notice translation is right 2 up 3. So my vertex is right 2 up 3. It's at 2, 3. And then the v opens up with a slope of 3. If I then move that left 5, 1, 2, 3, 4, 5, and up 6, left 5, up 6. Notice my new vertex is negative 3, 9. Translating it doesn't change its shape at all. So it was a v that opened up with a slope of 3. It's still a v that opens up with a slope of 3. So y equals 3 times the absolute value of x. Notice to get to -3, my translation should be left 3 up 9. So left 3 would be x plus 3, up 9 would be plus 9. Example 4, the graph of y equals -2 times the absolute value of x plus 3 minus 4 is then translated up 9 units. We were asked what the range of the new graph is. Y equals -2 times the absolute value of x plus 3 minus 4 gets translated up 9. What is the range of the new graph? So my old vertex was left 3 down 4. So -3, -4. If I move that up 9 is going to change the y value of the vertex. I'm not moving it left or right at all. So my new graph's vertex should be -3. I start at -4 and go up 9, so that's 5. So if I were to sketch a super quick graph here, -3, 5 is my vertex. And my V needs to open down with a slope of 2. I don't care about the slope that much, but it is important that it opens down. Therefore, the range of that new graph is -infinity up to 1, 2, 3, 4, 5, which makes sense. That's the y value here. And then the last example problem gives us the graph of an absolute value equation, and it wants to know what the equation is. Write an absolute value equation for each of the following graphs. We are given a V. We need to write the equation. So when you're writing an equation, make sure you write y equals or f of x equals. You should have an equal sign in there. This vertex right here is right 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5. That vertex is at 5, 5. So to get my vertex at 5, 5, that means I need to translate right 5, x minus 5, up 5, plus 5 at the end. Should be inside the absolute values. That's what makes it a V. And then out front, the V opens down, so I know it's a negative number, and it opens down with a slope of 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Y equals -3 times the absolute value of x minus 5 plus 5. The second one here, my translation is left 1, 2, 3, 4, down 1. So y equals, I've got absolute values because it's a V. I need to go left 4, x plus 4, down 1, minus 1. And this V opens up, so it's going to be positive with a slope of up 1 over 2, up 1 over 2. That is all I have for today's notes. If you're having questions, please reach out.